you could build it yourself. It's time to explore the future of space tech with Mouser's 2016 ISS Design Challenge, sponsored by Intel and Amphenol. We're here at NASA's Ames Research Center to meet with Made in Space, the revolutionary company that created the world's first zero-gravity 3D printer.
Made in Space was started to be the first space manufacturing company, and our vision is really that for the history of space exploration, everything has been sent into space on a rocket. That means that we're constrained to the shape of our objects, we're constrained to the fact that it has to survive the loads of launch. Well, what if we didn't have to launch anything at all? What if things could just be built there?
So I can imagine a few scenarios for 3D printing on the space station, like tools or replacement parts.
Everybody knows Apollo 13, so imagine if they had a 3D printer connecting that square filter into the round hole. But now that it's available for anybody on Earth to use, we have a lot of interest from commercial companies, from academia, and even individuals who are designing things that they've wanted to fly to space, but it's always been too expensive to launch it.
Now for this challenge, we had engineers, makers, and students from universities and labs across the globe compete to design a useful device for astronauts. We had a lot of entries, from simple tools to fun games, and even a prosthetic nose that improves the taste of astronaut food. But in the end, 3 designs rose to the top. Let's count them down. In third place, Thomas Delmas with a design for a vise that could be used to fix things in space without them floating away, because zero gravity. In second place, Elsie Clough with a design for space tongs that allows you to both scoop and grab food while eating from a pouch. And the winner is actually here with us. Let me introduce you to Andy Philo. Hi, Andy.
Hi, Grant.
So let's talk about the femto satellite. What exactly is it?
This is a femto satellite.
Okay.
It has a microprocessor, it has a number of sensors on it, a magnetometer, a gyroscope, and then we're also using the memory. These are things that can describe asteroids passing by, coronal events from the sun, and cosmic rays from the stars.
So, how does the 3D printed part interact with the femto satellite?
This represents a section, but each one of these little gills holds the femtosat. So I would successively then load these in, and the spring will actually fling them out like little frisbees. We would actually print this on the printer itself, but to study this deployment phenomenon in detail, we can then deploy the femtosats inside the space station and watch the first critical 5 to 10 meters of these coming out of a deployer.
So this can all be done by an astronaut that's floating around and all the stuff is floating around.
I don't need a table, I don't need a floor, I don't need gravity.
Now you mentioned that the femtosat has a microprocessor on board. What kind are you using?
We use the Intel D2000 Quark. It's the first Intel processor that's extremely low power. It also has a DSP on board that can analyze sensor data. So now we can actually pump that data through at a high speed and get the fidelity that we're looking for.
And it also makes sense that Amphenol is one of the sponsors because they've been making connectors since, okay, not since the beginning of time, unless you say, what, Apollo 11 is the beginning of time, and they've got connectors that are already on the ISS. So what's next? Andy will work with Mouser and Made in Space to develop the femto satellite. Then it will be beamed directly to the ISS so it can be 3D printed and potentially used by an actual astronaut. To see the winning design in action in space, subscribe to Mouser's YouTube channel so you don't miss